PLC programming, yeah? Lots of manufacturers, lots of people that want to sell you PLC training, they don't tell you the realities of everything that comes before PLC programming. And in this video, I'm going to share that with you. I'm going to share the realities of the things that they don't tell you, what goes into systems before you should even think about doing the PLC programming. So in this video, I'm going to go through all of that, and I'm going to do a little bit of PLC programming with you. So let's get into it. Okay, so you've clicked on this video because I've titled it something enticing, like what they don't tell you about PLC programming. But the reason I'm titling it like this is because I want to share something with you which people don't know about. And I want to show you, if you want to progress to becoming a PLC programmer, you cannot just jump straight into doing the PLC programming. Now, how do I know this? And why should you listen to me? Let me just show you and explain to you why that is. So I worked at Loxon, and Loxon are a manufacturer of a control system, ultimately, a PLC control system used for home and building automation and smart home. And you can verify this by going to LinkedIn and check out my profile, and you can see, if you scroll down, I worked at Loxon for about 1.5 years as a partner coach and a tech support engineer. And as a partner coach, what I did is I helped engineers and electricians grow their businesses using Loxon, in home building automation with a bit of industrial here and there. So I actually helped some of these guys. I know some of these guys personally, and I helped them with their businesses. But what I also saw through the many trainings that I ran, I used to run training for 5 days in person where engineers and electricians, they'd want to start delivering control and automation projects. So they'd come on the manufacturer training with us at Loxon, I would train them, and then they would go away and, they would join expecting to be able to go away and then deliver control and automation projects using Loxon. But there's a massive problem there, and I want to go through what that problem is in detail. So ultimately, these manufacturer trainings, all you do is you focus on the programming. If you go to any manufacturer, whether it's Loxon, whether it's KNX, whether it's Trend, Tridium, Control4, Schneider, any of these manufacturers, it's all focused on the software. Just like this, this software here, this is a good example for Loxon, where ultimately you're focusing on doing programming and understanding the software, because there's not enough time to cover everything. So that's really their priority, so you know how to program. But the issue with that is, let me explain what the issue is. So let's take a project, for example. Let's just take a very simple smart home project, okay? And this is a home, okay? To deliver that project, we can't just know how to program a system, because when you actually break it down, the programming is really the last thing. The PLC programming is the last thing in a project, okay? And that's usually done just as you've finished building the system. You can either do that in the workshop before you send it to site, or you actually do that on site, and there's always some recommissioning on site when you're doing, the on-site commissioning and then client handover, and then you'll also do some additional programming after the fact to do some optimization. So it's the last thing in this whole process of delivering control and automation projects. But manufacturers, they don't tell you this because they just want to get you in, they want to get you locked into their system. You've invested time, money, understanding their control system, then that means you're most likely going to then start buying their hardware, and then you're just going to work things out from there. And the amount of takeover projects that I've been on where people, engineers and electricians, they've been sucked in, because this is what manufacturers do, they've been sucked in, they jump on these 5-day trainings, they skip right ahead to the last thing in the process, the PLC programming, they leave, and then some of them just are too overwhelmed, they don't know where to start, they don't know what this starting point even looks like, and then what step 2 looks like, and 3 and 4 and so on. They just don't know where to start, so they just go back to doing exactly what they've been doing, just standard electrical work, standard engineering work, and they don't make any progress. Or the other people, the slightly more bold and brave people, they they win a project, they win a smart home project, for example, and then they do all the pricing and whatnot. And then the reality of actually delivering the project comes into play. And then they have to kind of work out what these steps are and learn as they go. And more often than not, they don't price things correctly and they don't actually know how to deliver things correctly. So all of these steps aren't done correctly. They don't allocate enough time for themselves. They don't, as I said, don't price things correctly. And then ultimately, the project just comes a complete shit show. They get stressed out, they've lost money on it, the client's unhappy, and ultimately they don't want to go through the stress of supporting it anymore. They don't really know what they're doing. They don't really even understand the programming, even though they've been on a 5-day training, because they don't really understand these things that come before it, that underpin the programming. So what happens is they're so overwhelmed and stressed out from the experience that they go back to doing what they were doing, and then the client's just left with a shitty system that doesn't work. And then they have to find people like me and other experts who can put their systems right. So the client's then paying twice ultimately. And the good people always charge a premium because they know what they're doing. So what I want to explain to anyone that's watching this video is, certainly if you're a beginner getting into this industry, whether it's, and it doesn't matter what industry it is, whether it's smart home, whether it's commercial BMS, whether it's industrial controls or instrumentation, it's all the same thing, okay? So I just want to detail out what you should do before you jump on a manufacturer training and before you even consider doing the PLC programming, okay? So the first thing that you should do, and this is what we teach our guys in our program, and we go through this systematically step by step. The first thing is the what, understanding what systems are all about. So this is the first stage, the what, okay? And the best way that we found to do this is to look at schematics. Look at schematics from a bird's eye perspective, a bird's eye view. Let me just write schematics. So we look at schematics from a bird's eye perspective, but also all the other supporting documentation in a real world project. And what we're also doing, so let me write docs. And then what we're also doing is we're then referencing the system that we design and build and test later on. We're referencing images of this real world system. So when we're looking at these schematics, when we're looking at these documents, it's actually translating into something tangible that can actually make sense up here and isn't just like a load of, symbols on a page. So that's the first thing. We're starting to build up a conceptual, not just conceptual, but also applied to, the real world system. So that's the first thing, understanding the what, which really is schematics, documentation, RTFM. That's another big one. Some of you may know what that means, some of you may not. So I'd encourage the people that don't to look into what that means, RTFM. Now the second thing is the how. Okay, so we know the what now, what systems are all about. Now we need to know, well, how do we go about building a system? Like that's it's not the first thing, and this is important, and I'm going to get into this in a bit more detail. When you're delivering a project, chronologically, anyone that's got any experience, chronologically when you're delivering a project, you'll always start with the specification, and then the design and documentation, and then the build. Now we don't approach it that way, because if you're new and you're new to control systems, diving into the design first, it just doesn't make sense. You can't piece things together. Just like jumping straight into the PLC programming doesn't make sense. So the next stage in this process is we look at how you go about building a system. Okay, how you build. So let me write this. Let's just put panel build, because that's easier to understand. Panel build, okay? How do you build a system from scratch, step by step? What does that process look like? So when you do see a panel, for example, on site, and you open it up and there's all these cables, you're not completely overwhelmed and stressed out. You actually know the process, how you get from A to Z in terms of the panel build. And this is then referencing these images that we've looked at earlier. You know, it's going through that build phase, you know, that we've already looked at, that we've already got a bit of an understanding of. So how do you go about building it step by step? Then after the build, the next phase, chronologically, is the testing, okay? So then, how do you go about testing a system? So that's the next thing. That's pretty self-explanatory. Testing it, making sure that it's working as designed, as specified. But then inevitably, what happens is you're going to encounter faults where you've been building or wiring the panel, or where it's been incorrectly designed or specified, or whatever. Inevitably, there's going to be faults. There's going to be problems. So this is then the next phase where you fault find, ironing out these faults that have been created here. So that's the next thing that we're looking at. And then after that, so how do you fault find? How do you actually isolate and break down this system to find those faults? And then what you do is you basically get it pre-commissioned, ready to be sent to site. Okay, so commissioning. All right, so how do you then commission a system ready just to send it to site? Because you don't want to be spending time on site commissioning systems, because it's just a nightmare. Anyone that's been on site, you know what it's like on a construction site. It's faffy, there's people delaying you, there's just on-site pressures, people breathing down your neck, there's dirt and dust that can get into the system. It's just expensive. It's the time that you can charge the least for, but when you actually look at it, it's the least productive time, and it makes it the most costly. So we want to do as little as we possibly can on site. So we pre-commission it off-site. So that's step one. What is it all about? Then step two, how do you go about building it, testing it, fault finding it, pre-commissioning it? Then the next stage is, grab some water. Now, we've got a good enough foundation here, and we've now started to build on top of that foundation, understanding, well, how do you go about actually building a system? So we've got a tangible understanding in our head of what this looks like. How do you test it? How do you fault find it? How do you commission it, as I just mentioned? So now we're in a good position to actually better comprehend the specifying, design and documentation process. So that's the next thing. And this is also, well, actually, no, this is the why initially. So why has this been built like that, tested that way, fault found? We can now build up a picture of why this has all been done that way. So let me just go, why, but then how? So now we're doing the process, going through the process of how you actually go about specifying, design, documenting a system. So this is both why and how. So the first thing is specifying, not specifying, design, and then doc. Okay, that process now makes sense because we've got something tangible to relate it to. Pretty self-explanatory, not going to go into that in any more detail. Okay, now we are well positioned because there's nothing more to do now. If you think about delivering a project, if we're going through things in a chronological order from start to finish, if we know what we're doing, the first thing is, well, we want to spec the job, okay, and then we're going to do the designs plus documentation. Then once we've got all the documentation, we've created our bill of materials, we've ordered our bill of materials, we can then do the build. We can then do the testing. We can do the testing, and I'm going to put pre-commissioning here as well. And there's probably some installation work going on as well. And when I say pre-commissioning, we can also do a little bit of programming here, so some PLC work. But then now, finally, the system is kind of now on site, the installation's been done, and it's time to do the on-site commissioning. I'm trying to write quickly, plus programming. PLC. Okay? And then what you would do, if you're doing things right, about 2 months later, depending on the project, you'd then come back for an optimization visit, where you'd probably do a little bit more. You'd speak to the client, you'd understand how they're using the system, if things are working correctly, and then you'd probably make some adjustments. If it was a smart home project, just for simplicity's sake, you would understand how they're living in the property, what changes need to be made, and then you'd adjust the programming. So you can see, right, really, the bulk of the PLC programming is done in step 6 and 7, a little bit here in step 4. But if you don't know how to specify properly, design and document properly, build and test and pre-commission properly, you've got no concept of what underpins the PLC programming. So when you do come and do the PLC programming, there's a disconnect. There's too much of a gap and a gap of knowledge that's missing that just causes that problem that I talked about earlier, where people just get overwhelmed, stressed out, deliver crappy systems. So in what we do and what we encourage our guys to do is this is like the final thing to really focus on, right? And then also, what you want to bear in mind is, well, what PLC / manufacturer system do you want to use? Like, it takes time to learn these systems, so you want to make sure that the system that you're investing your time in and the brand that you're associating yourselves with is the right one. You know, do they provide the right trade discounts, a high enough trade discount? Are they reliable? Does the software and the application that they're generally used for match the projects that you're going to go with? So for example, if you know that you want to do high-end luxury smart homes and cinema rooms with a heavy emphasis on audio visual, then you might want to go with a system like Control 4. If you're dabbling in smart home BMS, commercial BMS, you might want to go down, so like either or and cover both bases, you might want to go down the Loxon / KNX route. Or if you're just fully focused on commercial BMS, you might want to just focus on Trend or Tridium or Cylon or Distech. Like there's loads. So, and then finally, before I move on, if you're then just focusing on industrial applications, then you might want to go with Siemens or Rockwell or one of these other ones. So these are things to consider when you're going down the PLC programming route. You know, all of these things I just mentioned here, but also, you know, making sure that you've got an understanding that underpins the PLC programming first. Now, it wouldn't be fair of me not to actually do a little bit of PLC programming for any of you that are here. So let's just do some simple PLC programming just to make sure that you get that feel, that kick of actually seeing some programming. Now, what I'm using here is Loxon's config. I have no affiliation with Loxon. They really irritate me with a lot of the things they do, but there's a lot of good things that they do as well, which I really like. And I'm very familiar with Loxon because I used to work there. What's great about Loxon is you can download this software for free and start getting familiar with function block programming, which is the most intuitive way to do programming. You're not doing ladder logic, you're not doing structured text programming where it's more like you have to be a software developer. This is very visual, drag and drop, which is great, and you can download it for free, which is something that I commend them for. So let's do a little bit of programming. Let's say that we've got a switch, let's keep it simple, a switch on the wall, and we want to switch on a light on the ceiling. And the great thing about Loxon is they've got all these, you can do anything, okay? And what they do have is these predetermined blocks depending on what you're doing. So let's just do a simple switch block. And I always like starting with the outputs. So if we just hover over here, output, O is the output. So what I'm going to do is I'm just going to drag a digital output from over here onto the page. So this is just like a relay digital output, capable of like 10 amps, I think it is, Q1. And then what we're going to do is we're just going to connect that to the output. Now what we can do is we can look at these inputs. So TG is a toggle, off is an off input, and on is an on input. So now what we can do is let's just create a virtual input. In reality, it's going to be, actually, no, we don't, we can use a digital input. So now we need to put our physical input onto the page. So let's say we've got just a retractive switch. I'm going to press that retractive switch. That's then going to trigger this in the programming. And if we put it into the toggle, that's then going to toggle this output on or off, depending on how I press it. So let's simulate this, and this is another thing that Loxon does very well, which I like. So if we go up here, testing, start simulation, and we want to mimic a retractive switch. So that's just switch on and off at the moment, which doesn't represent a retractive switch. So I'm just going to select that, and I'm going to go over here, simulation live view. Typical, the washing is going. Hopefully that's not too distracting. But now this is like a retractive switch. So when I press it, it stays in, and when I retract my finger, it's not held in. So if I click here, and because we've got it set to a toggle, if I click it once, click, the relay, the light comes on. If I click it again, click, the light goes off. And if I hold it in and then release, the light's on, as you saw, and then the same thing in reverse. Now what we can also do, let's now get into a bit of simple logical programming with anyone that's familiar with controls and instrumentation would be familiar with an AND block and an OR block or gate, however you want to refer to it. So let's, similar situation, let's take this same lighting output, and what we can also do is we can connect multiple controllers or blocks to the same output. So let's just do that, why not? And again, I'm just going to connect both outputs of this and OR block to the same output. And now let's add some more digital inputs. So let's just again think of these as retractive switches. So we've got input 2 and 3 on the page, and then 4 and 5. And let's connect those to this AND block and this OR block. And I'm not going to read that because I'm going to explain exactly what's going to go on. What's happening, sorry. So let's connect these and let's put it back into simulation mode, which I think it already is actually. Oh no, it's not. So simulation mode, zoom in a bit. And we want to change them to those retractive switches again. So I'm just going to highlight those, go over here, switch, normally open, because that's most likely how most retractive switches are configured. And then let's see how a AND block behaves. And again, this is our lighting output Q1, which is a relay, but then what's wired into the relay is a light on the ceiling. So we press input 2, nothing happens. And again, we're using retractive switches. So we press it in, nothing happens. We press the other switch, because we've got 2 retractive switches now. Press the other one in, nothing happens. Now this is going to be hard for me to demonstrate because I've only got one mouse, but let's say that I pressed both retractive switches in, and this is where I'm going to have to change this back to a switch so I can pretend that one hand is pressing. So let's bring that on. So this is now on, and input 3. So input 2 and input 3. And you can see that the output comes on. So on, off, on, off. So that demonstrates the AND block. Now let's look at the OR block. So let's switch this off. Now the OR block, we need input 4 or we need input 5 to make this light switch on. So let's have a look at what happens on this one. So input 4, on. Ah, the light has switched on, okay? Off, the light is off. On, this is going to be difficult. Off, on, off. I think you get the point, right? and then we can go to input 5. So this other switch, on. So yeah, pretty simple stuff, but hopefully that paints a picture of how you do a little bit of basic programming using very basic logic gates. Now, if you want, we can help you develop your career or business in the controls, automation, BMS, smart home industry. If you're interested to learn more how we might be able to help, click the link in the description. See you later.